Alright, this video is probably going to be like 1 minute long, but this is the series. This is another series test. This is more of what should have been an introductory video to the series. That's actually kind of funny, the series. These are called series, these examples, but, yeah. So let's just say that we have a summation. Man, that's like the worst, like, sigma in my entire life. So n equals 0 to infinity, oh, yeah, that's fine. N equals 0 to infinity. And let's say we've got 5n plus 1 over 2n plus 2. So we're testing for divergence, basically. And this is actually called the nth term test. And if the limit as n approaches infinity of a sub n does not equal 0, the series is divergent. Otherwise, it's convergent. So basically, it has to be 0 for it to converge. So it's really, really easy to remember this test, because if it's any number but 0, it diverges. So it's really easy to test whether or not it diverges or diverges or converges. Diverges. Anyway, so this is our series. So what we're doing is we're taking the limit as n approaches infinity of 5n plus 1 over 2n plus 2. Now, I haven't actually... This is pretty much a limit problem with infinity in it. But what you've got to do for these kinds of problems is I divide each term by the highest power variable. So I've got n to the 1 and n to the 1 in the bottom. That's the highest power variable. So what I have to do is I'm going to rewrite the problem. I'm going to take the limit as n approaches infinity of... So if I've got 5n, so what I'm going to do is I'm going to write 5n over n plus 1 over n. But what I do to the whatever I do to the top, I do to the bottom. So this is 2n over n plus 2 over n. See, basically I've divided everything by n. So the n's will cancel, and that's mathematically fine, because whatever I've done to the top, I've done to the bottom, so it's still the same thing. So it's now the limit as n approaches infinity of 5 plus 1 over n over 2 plus 2 over n. So what's the limit as n approaches infinity of this? Well, if I plug in infinity, this is 5 plus 1 over like a trillion, a gazillion, a quintillion. I can't think of any other bigger number. A Google. Oh man, I don't like the number Google because it just makes me think of Google. Anyway, this is going to go to 0, this is going to go to 0. So that means the limit as n approaches infinity of a sub n is equal to 5 over 2, which means that this series is divergent because it doesn't equal 0. Now, that's it. Pretty much, it doesn't equal 0, so this series diverges, and that it makes sense, yeah, when you think about it. If you added, so 0, 1, 2, 3, 4, 5, 6, 7, you'll note, and here's why it's going to diverge, because the numerator is going to grow quicker than the denominator when you think about it, because 5 times 1, 5 times 2, 2 times 1, 2 times 2. This is going to eventually be a bigger number over time than this, no matter what. But it's going to take a very long time. But that's why it makes sense that it would diverge. So, yeah. Anyway, that's the end of the video. So this is the first example for testing the series for divergence, the nth term test. I hope this helped, and yeah, see ya.